Now before we go to the equation, let us first draw the ray diagram ourselves, because we had just looked at the simulation. So let us draw the ray diagram. This is the concave mirror. This is the non-reflecting side of the concave mirror. This would be the principal axis. Let me cut this a little bit here. Right. This point is called as the pole of the mirror. Now at a certain distance, because we need to have a clear estimate, so we will mark this here. This is the focal point, and at the same distance roughly here we will say this is the center of curvature. Right? I could have readily shown you a diagram which is already there on the screen. I did not do it on purpose. The reason is, when I draw it like this, I hope you will catch on to that point, and when you draw it in your notebooks, you will also have a rough estimate, a small pencil or the cap of a pen, and make sure that the distance between P to F is same as the distance from F to C. That is essential. That is a defining point of a spherical mirror. Now, in case of mirrors, we use the formula which is the mirror formula, 1 by F is equal to 1 by V plus 1 by U. F is the focal length of this mirror, and I hope you are already familiar with what the focal length is. If there is a parallel beam of light incident on the mirror, then all this beam will come to focus at this point called focal point, and the distance of the focal point from the pole of the mirror, that is what is called as the focal length. Then comes object, this one, object distance. I could place the object here, I could place the object here, here, anywhere on the principal axis. Let us say we keep the object here. This is the object. Now light rays from the object will naturally spread out in all directions. You might have lit a candle, or you might have lit a lamp, or you might look at a bulb. Why would light ray go only in one direction? It will naturally spread in all directions. But can we handle all those directions at the same time? No, it is neither useful nor is it meaningful to handle all those rays at the same time. One ray is sufficient for us. There can be a ray going here, there can be a ray going here, there can be a ray going here. Let us not bother about all that. We will take one ray hitting the mirror, upon reflection passes through the focal point. This is one ray. Another ray hitting the pole of the mirror will come back making the same angle. Another ray hitting the pole of the mirror will come back making the same angle. So this is where these two rays meet, and this is where I say this is the image formed. The reason why I did this is because now we can mention what is the object distance and what is the image distance. The distance of the object from the pole of the mirror, this is object distance. The distance of the image from the pole of the mirror, this is the image distance. Object distance, image distance, focal length. You are already familiar with this. When any questions are asked in ray optics, neither are the quantities in the question given with the sign convention, nor do you have to quote the answer in the sign convention. But the unfortunate thing is, the mid portion where you come from question to answer, the rest of the solution has to be done with sign convention. That is the irony of it. So they will not say consider a concave mirror of focal length minus 20 centimeters. They will just say consider a concave mirror of focal length 20 centimeters. Depending on the sign convention, you have to decide whether it has to be plus or minus. Now for sign convention, I could have directly said you that take this as positive, take this as negative, but that won't serve the purpose. Let us understand it in such a way that you won't remember that, you won't forget that for the rest of your life. Sign convention. Sign convention is to help us decide where an object is, in which direction is it moving, and so on. Suppose, you are waiting for, some Swiggy order or something, or Amazon order at your house, and you get a phone call from that Amazon fellow. And he will say, sir, I am, calling from Amazon. And how should I come to your house? Would you directly say, oh, you are the Amazon guy, 500 meters, that's it, you will reach my house. Would you ever say that? God knows where he is. Probably he is calling from Begumpet or Amirpet or Sainikpuri. He could be calling from anywhere. So how can you say that directly it is 500 meters, come down to my house? So what is the first thing that we generally ask? From where are you speaking? From where? Isn't that a very important thing? Likewise, if you want to speak of object distance, image distance, is it not very common that you must decide from where you are going to choose all those distances from? That important point is the pole of the mirror. So all the distances, whether real object, virtual object, concave mirror, convex mirror, plane mirror, whatever it is, once it is said that everything has to be measured from the pole of the mirror. That's it. So now we know from where the distances are being measured. Let us come back to that Amazon guy example once again. So now you find out where he is and you realize that he is at so and so crossroads, and you say, okay, so you are there, 500 meters, come down. So now the distance is fixed, but you said 500 meters. You thought he will take the straight road in front of him 500 meters, and he thought you are speaking of the right hand side turn, and he goes off in that direction. Will he ever manage to reach your house? But the magnitude is correct, 500 meters, he will go and deliver the package at someone else's house, or will start fighting there. So not only is the initial position important, direction is also important. You would generally say, okay, so you are at so and so place, come 200 meters in the same road, then take a left turn, then the third house. You will give all these directions. So when that is plain common sense in daily life, it is exactly the same common sense in physics also. So we need a direction, because there we can say go east, north, south or west, but here how do we say the direction? So the next important thing is to figure out the direction. In this entire scenario, the only direction that is fixed or that is easy for us to consider is the direction of the first ray of light, right? It has to be from the object, it has to be towards the mirror. There is no other possibility. So isn't this the best choice amongst all the other directions that you see? So the direction of the incident ray is taken as positive. Now let us keep those two things in mind. So origin, from where you measure all the distances, is pole, and direction is decided by the incident ray. If these two things are decided, then we will get the sign convention correct. Now suppose in this formula, if focal length is, let us say, 20 centimeters, object is located at a distance of, let us say, 30 centimeters, and our job is to figure out what the image distance will be, right? I am using the same formula here again. So our job is now to plug in all these quantities with the sign convention and then see what do we get. Let us write 1 by f. F is 20. Number will be the same, but then focal point is here. You have to start measuring from here. So imagine that you have a small measuring tape in your hand, you hold that tape in your hand, and as you are unrolling the tape, you go up to the focal point. That is how we measure the length of anything. If you have to measure the length of this room, you will start at that end, keep unrolling the tape and end where you have to end. Simple day-to-day process. That is what we are doing here also. So you start from here and you start unrolling the tape. When you are unrolling the tape, you realize that you are going in this direction, light ray is coming in the opposite direction. Opposite in mathematics means negative. So negative. Fair enough. That is how we decide the sign. This is equal to now 1 by what shall we put for V, plus or minus. Once and for all, remember, not only in ray optics, every other branch of physics, any quantity for which you are trying to find out, never ever prefix a sign, because we are not telling fortune here, right? We are not telling future here, right? We are just finding out what the quantity is. If we were to already decide whether this is plus or minus, then why are we solving all this? We already know the answer, right? The big idea is that we don't know the answer. So if we don't know the answer, don't put either plus or minus, just leave it like this. This plus is there in the formula, write it like this, and this is 1 by, first write the number 30. So once you write this 30 here, now let us come back to the sign. So now you are at focal point. Now you should not start measuring from there. Come back and come back to the origin, that is the pole, right? Now keep unwinding your tape and keep on going up to the object. While you are going, again look up. What is the incident ray doing? It is going in the opposite direction. You are going like this and the incident ray is going in the opposite direction. If it is opposite direction, minus. That's it. Now solve for this. So 1 by V will be equal to, this one will come this side, 1 by 30 minus 1 by 20. I am not going to solve this for you. That is not even the intention. But just by looking at this number, can you tell me whether it will be positive or negative? 1 by 30 is a smaller number, minus 1 by 20 is a larger number. So it is obvious that V will turn out to be negative, right? And look at the ray diagram. What does this say? From the pole, light ray is going like this, but in order to search for the image, you have to go opposite to the light ray, opposite. That is the same thing that you will get here also. That is the sign convention in ray optics. I hope the first example is clear, right? Now we will take up another example.